Hey guys, if you need to practice partial fraction decomposition, then I have a lot of examples in Algebra 2, in my Algebra 2 video, so check that out. But yeah, you're going to need to know at least some partial fraction decomposition in order for you to solve this integral. So let's get started. So to start, we're going to notice that we can write 1 over x squared minus 1 as 1 divided by x plus 1 times x minus 1. And then we're going to take these linear factors and put a constant on the numerators and claim that we can write some constant a divided by x plus 1 plus some constant b divided by x minus 1 must equal, this must equal 1 divided by x plus 1 times x minus 1, which is the same as 1 divided by x squared minus 1. So this is the partial fraction decomposition part of this problem, or the solution. Okay, now we're claiming that this equals this. If that's so, we should be able to find common denominators here and then set the numerators equal. That is, once we find a common denominator here, we can take the resulting expression and take the numerator of the resulting expression and set it equal to 1, because that must be true if these two things are equal. This is what I mean. So next we're going to do this, which is we're going to multiply by x minus 1, numerator and denominator, right? If we multiply the denominator by x minus 1, we must multiply the numerator by x minus 1. So ask to multiply by 1, but you know that. Now, in the second expression, or in the second rational expression, we're going to multiply by x plus 1, numerator and denominator. And now notice this is x squared minus 1 in the denominator, as is this, which is the same as that. So we're happy with the denominators. So what we need is for this plus that to equal 1. And this is what I was talking about a little bit ago. So we have this all-important equation, a times x plus 1, sorry, it's a times x minus 1. So a times x minus 1 right there, plus b times x plus 1 must equal 1, we see. All right, so if that's true, then for suitable choices of x values, because this has to be true for all x values, but for certain choices of x values, we can make this equation very simple. Specifically, if we let x equal 1, notice this is going to be 0, and this is going to say 2b, and the right side will be 1. So we have 2b equals 1. Notice the right side is independent of x, but this has to be true for all x. And so with x equaling 1, this is 0, this is 2b, so we have 2b equals 1. From which we gather that b must be equal to a half. And similarly, if we let x equal negative 1, you should have seen that this is the other good choice of x, then this is going to say negative 2a, whereas this is going to be 0. So when x is equal to negative 1, we'll have negative 2a plus 0, right? Negative 2a plus 0 equals 1. So negative 2a equals 1, from which we gather that a has to equal negative a half. Awesome. Because what does this mean? Well, if we go back and undo a little bit of something we did, which is getting common denominators, we would have had that, as we'd written, a divided by x plus 1 plus b divided by x minus 1 is equal to 1 divided by x squared minus 1, where a and b are now 1/2 and negative 1/2 and 1/2. So we now know a and b. So then we know that 1 over x squared minus 1 is equal to a, which is negative a half, divided by x plus 1, and then plus b, which is positive a half, divided by x minus 1. This is awesome, because now our integral, which is the integral of this, could be thought of as the integral of this plus the integral of this. Yeah? And these guys are much easier than the integral we started off with. So that's what we're going to do. So using what I just showed, and let me delete a bunch of stuff we don't need. We don't need any more anyway. So we don't need that. So what we're saying is now our integral is this, and we can instead compute these two integrals and we'll be done. This first one, notice I could factor out the -1/2, or I can take out the -1/2 in front of the integral and write simply as -1/2 times the integral of 1 over x plus 1 dx, which is a pretty simple integral if you saw example 7, right? And then this guy, similarly, I can take out the +1/2 and write I have 1/2 integral of 1 divided by x minus 1 dx, which was in fact example 7 exactly. So what we're going to do now is we're going to make room here and finish. Specifically, we're going to write, stuff is bothering me here, so let's delete some of this and some of this, sorry y'all, and a little bit of this, and we're done. Yeah, because we've got ourselves the following, which is we've got -1/2 the natural log of x plus 1 plus c, but we're going to combine two constants into one. We get a plus c from this and a plus c from that, c1 and c2 if you'd like, but we're just going to write 1c. But we have plus 1/2, and then it's ln of x minus 1, and then here's the much talked about plus c. Yeah, cool. There's a little bit of simplifying you can do if you'd like, which is, you know, you could write, you could take out the -1/2 and then write that you have the natural log of x plus 1 minus the natural log of x minus 1, and then apply log rules, and then you have plus c. And remember, ln of a minus ln of b is equal to ln of a over b. So now we can write that we have -1/2 times the natural log of the absolute value of x plus 1 divided by the absolute value of this is the argument of log, so let me make it look like that. So divided by the absolute value of x minus 1, and then you can even use the log power rule to take care of the -1/2 in front, but you know, I've led you to the water, so to speak, so this is good enough. In fact, we could have claimed our final answer was right there. Yeah, okay, take care.